So today, 3, 6, 15, 3.5, and 4.1 focus on dilations, parallel lines, transversals, and angle sums. This is a lot of review, so these should come easy if you remember things from 7th grade, especially about triangles. Okay. So 3.5 parallel lines, transversals, and angle sums. You are using lab sheet 3.5, which actually comes out to about a page and a half. Okay. Now, it is pretty straightforward. It says when two parallel lines are cut by a transversal, what can be said by the angles formed? And they walk you through each step. When you start rotating this around point M1, you'll start to have parallel lines and a transversal, and they make connections between the lines. Okay, we'll start working on this together. Oh, well, actually, go ahead and cut this lab sheet out, or if you'd like to, you may work directly on the lab sheet, glue or staple it, create a pocket into your notebook, and place it in there, and we'll talk about what you came up with. It's fairly straightforward. It tells you to rotate on the midpoint of AB, the midpoint of BC, and they'll eventually have you find the midpoint of AC and rotate around there, and you end up with mirror images, or not mirror images, rotations from each side, and you'll find parallel lines and transversals, and you'll connect angles 1, 2, and 3 into a straight line. A lot of review from 7th grade items and angle sum theorem. Okay. If you get stuck on any one of these questions, we'll review them in class, but they are fairly straightforward. This picture on picture D represents what it looks like to. So this is when you rotate on every single side, so the midpoint of AB, BC, and AC. You end up with these three triangles around here. You'll find parallel lines cut by a transversal, and where angles 1, 2, and 3, what do they make together? So this should be fairly simple. Just cut out the lab sheet, answer the questions, and we'll come up with a few questions at the end for you to answer. If you want me to go over it in class, we can. Pretty straightforward. 4.1 is the one that's a little bit new. So 4.1 is what they call focus on dilations. And the interesting about this is focus is actually part of what is on this graph, and dilations is what we use based on the focus. Okay, so focus question is what coordinate rules model dilations, and how do dilations change or preserve the characteristics of the original figure? This is 4.1 lab sheet. This is in the bottom of 3.5. You can go ahead and cut out questions A and C on there, and we'll answer these questions. I'll go over this with you guys together right now on how to do lab sheet 4.1. I'm going to zoom mine in a little bit more so it's a little bit easier to see. Oops, that's not good. We'll zoom in a little bit more, and I'll show you how to draw a dilation and where your focus is. Okay. So it says draw the image of the quadrilateral PQRS after dilation with a center of 0, 0. Now wherever your center is, this actually represents your focus. So this is your focus right here. So your focus is actually going to be this part right here. Your focus is where your lines are coming from. It's in for those of you who are very artistic, your focus is your vanishing point. Where does it vanish to? Where does it start from? Etc. Okay, so I'm gonna draw lines starting from 0, 0, our origin, and they're gonna extend through each point. Okay, so I'm gonna do this in a dotted line, and I'll do this in a separate color so you can see what it looks like a little bit more clearly. So starting at 0, 0. I'm going to go through point P, and I'm just going to extend all the way through it, okay, as far as I can. And I'll do the same thing, 0, 0, I'll extend through point Q, extend through point Q, and adversely, that's also point S. It's the same line as point S. And I'm going to go through point R, okay. So my focus is 0, 0. It's your, like I mentioned before, it's also your vanishing point. So your focus is actually this location down here. Okay, sometimes your focus can be somewhere else depending on where they tell you your focus is. Okay, now what I need to do is I need to replicate this distance, okay, from P, from the focus to my first point. I need to have a scale factor of 3. So that's a scale factor of 1. There's a scale factor of 2, double the distance, and a scale factor of 3. And that point should represent where my last P should be. Okay, so that actually was really difficult to read. So let's count this from 0, 0 to P. What I need to do is I need to go up. This is in blue. I need to go up 1, 2, 3, 4 spaces over 2. So if I go up 1, 2, 3, 4 over 2, that's 200% because that's a scale factor of 1, a scale factor of 2, up 1, 2, 3, 4, 1, 2, scale factor of 3. This is going to be P image. Okay, I have to go through it. A scale factor of 1 will be the same, scale factor 2 will be double, scale factor of 3 will be triple. Okay, Q is up 1, 2 over 1, 2, so that's 100. 1, 2, 1, 2, that's 200. 1, 2, 1, 2, that's 300. That's Q image. You know what? I'm going to erase these other dots because they're going to confuse me a little bit later. So I'm going to get rid of these. Okay, I found my first 2 images. Okay, for the next one, it's 1, 2, 3, 4, 1, 2, 3, 4. There's my 100%. 1, 2, 3, 4, 1, 2, 3, 4. There's my 200%. 1, 2, 3, 4, 1, 2, 3, 4. There's my 300%. There's S image. Okay, and what you know is the original point and its image should lie on the same line. If this is not on the line, then I did it wrong. Okay, my last one is up 1, 2 over 1, 2, 3, 4, 5. There's my 100%. 1, 2, 1, 2, 3, 4, 5. And I can just go up 1, 2 and go all the way until I'm back on the line again. Okay, and I'm going to erase these items here. This last dot that I put here should be my R image. I can play connect the dots from P, Q, R, S. So P, oops, that was not a very pretty line. From P to Q to R to S. I'll do this again in blue. So P to Q, Q, R, and S, and then back to P. Okay. Now, our focus question said, what remains? How do dilations change? How do dilations change? Well, what's the difference between our original and our new one? Well, the way that they change size. And size is definitely a product of scale factor. Okay. Now, your scale factor can be greater than 1. It can be less than 1. If it's greater than 1, so if scale factor is greater than 1, therefore it is an enlargement. Okay. If your scale factor is less than 1, it's a reduction. Okay, it gets smaller, right on space, reduction, etc. Okay, now what stays the same? Okay, well, this angle is a 90 and it's still a 90. This one's a 90, this one is still a 90. Okay, and these angles all preserve their same values. Okay, so 1, 2, 3, 3, and 1, 2, 3, 4. It's just really hard to get 4 in there, but use your imagination. They're all there. Okay, and they ask you to do the same thing here for scale factor for C, but the scale factor is 1/2. So if it's less than 1, your new image should be half the distance from the center or from the focus. Okay, and this is a little bit of a reminder from filling and wrapping that the area from one to the next actually doesn't double or triple here. The area from one to the next, I'm going to write this out as area factor. Area factor is equal to scale factor squared. Now, if this is a scale factor of 3 times larger, the area, so if the scale factor is times 3, the area factor should be 3 squared. Oops, area factor. That means if this is an area of, let's erase this so we can see it a little bit more clearly. If this has an area of 1, 2, 3, 4, 5 pieces, I can expect this to be 5 times 3 squared. I can expect this to be 45 square units long. 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. This section here is, including this section, is 36. This one is 1, 2, 3 by 6. This is 18 divided by 2, that's 9. 36 and 9 together make 45. It is area factor squared larger. This one was 5, and to get there, I multiplied it by area factor squared. So 5 times area factor squared, 5 times scale factor squared, which is area factor, gives me my new area for this item. Okay. Now, lastly, this is your rule. Let's start marking our points so we can identify what our rules represent. Make sure you copy this part down. This is important, okay? And this is important, okay? Make sure you make a note for focus. I'm running out of space. My pens are a little bit large, so I'm going to clear my screen a little bit. Okay, now let's value some of these points so we can figure out what we got. P is 0.2, 4. Our next point was 6, 12. 6, 12. Okay, so if I have P, which is 2, 4, and I have P image, which is 6, 12, what is our rule? How does one number become that one? And it should represent the same rule for that change there. Let's do this one more time so we can see if the rule is the same for more than one item. So let's use R, and R is 5, 2, 5, 2. This one is 15, 6. Okay, so let's put these two items together and let's see what our rules should be. And this was for R, which was 5, 2, and R image, which was 15, 6. How do these two items become this one? Okay, well, 2 to 6 looks like plus 4, but that doesn't work here. So 2 to 6 is times 3. 4 to 12 is also times 3. 5 to 15 is times 3. Okay, so our rule is times 3. So your rule should be x, y, 2, and let's write this out as, and this, let's hope it all fits, scale factor x, scale factor y. So I'm going to multiply the scale factor by my x value. I'm also going to multiply my scale factor times my y value, and this is my rule here. All of your rules should be written down somewhere for each one of these items. Okay. So that takes care of most of our items. All we have are our questions and our summaries. Okay, so here are some summary questions, and again, the questions you should be asking. So in your summary, try and answer these ideas. And this first one is specifically talking about 3.5. How does the triangle sum theorem relate to transversals, parallel lines, and transformations? Maybe how does transformations prove the triangle sum theorem? That's another good question that I forgot to write down. Actually, let's write down right now, just so you don't forget and you can see it. How does transformations prove the triangle sum theorem? Okay, what is a focus? That's from 4.1, and a dilation. What are those things and how do they relate to shapes? How does dilation change? What does it keep the same? And what are the rules for dilations? Questions, again, if you have anything stuck that you want to know the answer to, make sure you write it down. Questions, something that you think someone else might ask. And lastly, write down a test question. Okay, write down a test question that you think might be good to ask on a test. Test questions. Okay. Practice to follow.